From the chassis cab connector, the circuit you've been following continues to the lamps E3 and E4. To identify the lamps, you must refer to two different parts of the legend. Firstly, for the designations E3 and E4, the legend simply states left and right tail lamp units. These are referring to the vehicle's complete tail light assemblies, which, as you know, include a number of separate lamps such as brake lamps, indicators, and so on. To find out the specific function of the lamps E3 and E4, you secondly need to find out from the legend the meaning of the number within the brackets. As you can see, the legend identifies that 213 are the rear fog lamps. However, on the vehicle, there's normally only one rear fog lamp. Its position varies depending upon whether the vehicle is left or right-hand drive, so for this reason the diagram includes both lamps. Now answer this question. Click on the rear fog lamp symbol on the diagram that is correct for a right-hand drive vehicle. Yes, that's correct. The final item in this circuit to note is the rear fog lamp connection. The symbol on the diagram indicates a multi-pin connector, and the number 6 denotes that the cable is in terminal 6. For simplicity, the terminal numbers are visible on the component. However, because they're very small, you'll need to look carefully. At this stage, let's review what you've learned about the rear fog lamp circuit by animating it and briefly explaining how it functions. The rear fog light circuit is supplied with voltage only when the headlights are switched on. From the fuse F1, current flows down to the lighting switch. Moving the fog lamp part of the switch to the rear fog lamp position directs current through the switch to the warning lamp and up to terminal 8 of the 12-pin connector block X1. From X1, on the back of the base module, current flows to the bulb monitor unit and then back out at the connector X2. The circuit continues to the chassis cab connector X6.2 and then down to the appropriate rear fog lamp and ground. We've already explained that a number of bulb monitor units check certain exterior lamps on the vehicle. In the event of a bulb failure, it causes a change in the voltage drop across the resistor. This is detected by the monitor unit and results in a voltage signal being sent from its output terminal. The signal is received by the electronic bulb monitor control unit, located within another section of the base module. In response, the control unit dispatches a signal to the instrument cluster where the applicable display illuminates to warn the driver. The connection from the bulb monitor control unit to the instrument cluster is made via terminal 8 of connector X5 on the base module. Now use the interactive diagram to answer this question. On an Actros vehicle, to which terminal of the instrument cluster does the cable from the bulb monitor control unit connect? Click on the correct answer. Yes, that's correct. Similar to the identification of other connectors on the vehicle, X1 18/3 means that the connector block is designation X1, it has 18 chambers, and the cable is in chamber 13. You may have noticed that the diagram shows only the bulb monitor control unit cable connecting to the instrument cluster. It's a similar situation with other components on the diagram. For example, the left front indicator marker lamp and the ABS relay. The reason that the remainder of the circuits is not shown is to simplify the diagram and avoid unnecessary lines, which make it confusing for the user. To find the remainder of the circuit for any of these components, then you need to refer to the diagram for that particular system or component. For example, to find the instrument cluster's remaining connections, then you must refer to the instrument cluster diagram. To find the applicable diagram, you need to refer to the search aid for wiring diagrams. The search aid is normally in section A3 of the manual. To find the diagram, simply scan down the list to find the diagram title and the applicable model, and then note down the wiring diagram number. You can use the same technique to find diagrams pertinent to other systems. Having identified the correct wiring diagram from the search aid, let's explain how this diagram links to that of the instrument cluster. If you remember, the cable you are following was that which connects the bulb monitor control unit with the instrument cluster. To find this cable on the instrument cluster diagram, first note the designation of the component from which the cable is coming. In this instance, it's the base module A7. Now, to call up the instrument cluster wiring diagram, click on designation P2. To find the link between this and the previous diagram, simply look for designation A7, the base module. For simplicity of following the circuit, the only connection shown on the base module is that which connects the bulb monitor control unit to the instrument cluster. So to summarize, when following a circuit from one diagram to another, remember this sequence. First, note the designation of the component from which the cable is coming, and then refer to the next diagram and look for the same designation. This chapter briefly describes the CAN system and looks at the CAN wiring diagram. In addition, the chapter also looks at twisted cables and the symbols which represent them and the star point location. Now you're going to look at another symbol within the instrument cluster, that of the CAN controller. The CAN system communicates digital messages bidirectionally between the vehicle's different control modules. The system transmits data at high speed and helps to reduce the number of electrical cables by transmitting different messages along the same cables. Another benefit is that the signal from a temperature sensor, for example, which may be directly connected to one control module, can be passed on to all other control modules via the CAN system. This avoids separate circuits to each control module. This component is a CAN controller unit located within the instrument cluster. Its basic function is to process the high-speed digital signals received along the CAN cables and convert them into analog signals for use by conventional components. The controller distributes the analog signals to the relevant components of the instrument cluster, including the gauges. Although this particular controller is in the instrument cluster, you will find controllers in all control modules that are connected to the CAN network. This CAN system uses two cables. These are known as CAN high and CAN low. In addition to reducing the overall number of cables, the system has many other advantages. These include rapid transmission of signals and the easy integration of additional control modules for different vehicle specifications, such as those fitted with power takeoff systems and so on. The two CAN cables join at a central point at the front of the vehicle on the cab waist rail. This junction point is known as the star point connection. On the diagram, the star point connection is shown like this, with the CAN high and the CAN low cables clearly labeled. This symbol denotes twisted cables. Twisting cables together helps to cancel out interference caused by electromagnetic forces. You can confirm that this is the symbol for twisted cables by noting the numbers within the brackets and then looking in the legend. For protection from interference, twisted cables are also sometimes used for components such as speed sensors. Click on the twisted cable symbol to view some other examples. In this example, B30 is the symbol for the left front axle ABS sensor as fitted to an Actros vehicle. Component B36 is a left first front axle brake lining wear sensor. The virtual diagram will allow you to explore freely the lighting and CAN circuits. These include components such as the light switch, bulb monitor units, base module connector blocks, rear fog lamp, instrument cluster connections, and the CAN system. This virtual diagram is designed to let you explore freely the lighting and CAN circuits, enabling you to revise the items covered so far. You can navigate around the diagrams as you like and click on any of the highlighted components to receive an explanation. The navigation tool will help you to move around. This is a symbol for a bulb monitor unit. They're located in the base module, and each separate device is responsible for monitoring a specific light circuit. Each component has 3 connections. Only the lighting circuit connected to the bottom connection on the diagram is monitored by the component. This connector is one of a series of separate multi-pin connector blocks on the rear of the combined fuse box and base module. The letter and number, X1, X2, and so on, classify the individual connector blocks. This diagram will help you see how the blocks are arranged on an Actros vehicle.